All right, everybody, welcome back. It's Wednesday, lecture 16, I think, today. We're going to keep talking about functions. I did want to just remind you to, A, the midterm is available. It's due on Monday. But B, nothing that we're doing this week, including anything that we did on Monday, as well as today or Friday, is required for the midterm. You can use these ideas if you want. If you want to write a function for your midterm, by all means, write a function for your midterm. But it's not necessary for anything that we've done or anything that you'll be asked to do on the midterm. Our sort of outline for the rest of the class, at least today we're going to do functions. Friday we're going to do functions again. We'll probably be done with them around Monday or end of Friday. And then we'll start talking about the more sort of practical side of Matlab of using it as a calculator. Right? One of the things I want you to be able to walk away with when you leave the class is some other class had me solve for a variable. I know how to do that in Matlab, or at least I remember vaguely how to do it, and I can go look up my notes or look at the documentation and refresh my memory enough to do it. But that's a big part of the class because it comes up so much in all of your other classes that we're going to spend a couple of weeks on it. But for today, anyway, we're going to introduce functions. Oh, there was something else that was important. Oh yeah, there's no homework. So the only thing that's out right now is the midterm. So don't worry about looking for the other homework. The next homework won't be posted until after the midterm is due. Yeah, didn't want you to be worried about something else. So we're going to take some notes for the first maybe 20 minutes of class over in Excel to sort of draw out the way that functions work. And then we'll practice writing functions for the rest of the class after that. Admittedly, we're going to lay out all of these rules for functions, and the first time that you see them, it seems like an awful lot to remember. It is, I would say, most of it is important. Some of it's more important than others. But it's okay if it seems a little bit weird while we're drawing it out. Hopefully, it'll become more clear as we actually use the functions to do stuff. So don't worry too much if initially during the drawing part it seems a little bit much. It will become more clear as we continue to use functions. So I'm going to switch over to Excel for this portion. Just let me make sure that's there. Okay. The point where we had ended on Monday was we had introduced the three types of functions and we had compared them and contrasted them to scripts. The only two functions that we're going to work on for now are the standalone and local functions. Because those two types of functions are very similar in their syntax. You don't have to change their syntax very much. About the only difference between a standalone and a local function is where are they saved, which is a pretty easy thing to highlight, and we'll do that probably on Friday. We'll note the difference between the two. But we're going to leave that third class of functions, the anonymous functions. We're going to leave probably kind of like save the best for last. That'll be the last week of class before we get to anonymous functions because they work a little bit differently. So a couple of things to keep in mind. We're going to put some notes here about functions and a little bit about scripts. Scripts use what is called the base workspace. The base workspace in Matlab is the one that we've been using all along, right? Every time I've done an example and I said, go look over in the workspace and you can see the variable, that workspace I was referring to is the base workspace. Functions, though, have their own workspace. And specifically, they have one per function. So every function has its own unique workspace. And that's part of the challenge with functions is it can be hard to see what's going on inside of them because you can't see the workspace. So you can't run it and then look at what happened afterwards. But we will see some ways that you can use the debugger to look inside of that function workspace. There's two different ways that we can do that. A key feature, because there's two different workspaces here, is that data but not variables are passed between the two. Or just generally, they're passed between the workspaces, and they're passed as inputs and outputs. And I said that carefully, the data are passed, not the actual variable. So when you use a variable as an input or you assign a variable as an output, the variable itself is not along for the ride. It's just the data inside of the variable that go with the call to the function. So we're going to do a little bit of drawing here to visualize the difference between these. I'm going to insert some rectangles so that we can visualize the different workspaces. This big one over here we'll call the base workspace. This is where we've been working previously, right? The variables that are created here are the ones that you got by running scripts, for example. We've done that a few times. Less often, we've created variables over here by entering them at the command prompt. The command prompt is the little double arrows thing. That's pretty much the only way that we've entered stuff into the base workspace. There are other ways to do it, like you can import images and data and stuff like that. We haven't done any importing or anything like that. Most of that is handled by a GUI. You just say import data and it imports the data for you. But that's one other way that we could do it. So there are a few things we haven't done, importing data, loading images, etc. We have not done those, and you don't need to know how to do those. I'm just putting them out there in case you ever do them in the future. All of that data goes into the base workspace. An important feature is that all scripts share the same base workspace, which is why I put it as sort of the larger block over here in blue. There's only one of them. You only have one base workspace. It's the one that we've been using the whole time. There are, however, function workspaces, which I'm going to draw as separate ones over here. So I'll call this function A workspace. And we're going to color these a little bit different just so that we can tell the difference between the two. So I'll make this one orange. And I'll set it a little bit to the side because it's slightly different from the other ones. So these are new. We haven't done function workspaces before. Function workspaces don't, and I'll put in quotes here, see any of the variables in the base workspace. On the other hand, though, you can get the values. I'm going to actually put that in caps. Pass to it as inputs, or pass back to the base workspace as outputs. But the actual variables can't move. You can't move the actual variables, just their values. So there'll be an input here and an output down here. And I'll draw these real quick as, where's my arrows? There they are. So the input goes, generally an input is to draw something from the base workspace and put it in the function workspace, and the output of the function takes something out of the function workspace and puts it back into the base workspace. And you can have as many function workspaces as you want. In fact, every time you call a function, it creates its own workspace all over again. And they're kind of like ephemeral. They don't last very long. They only last as long as needed by the function to actually do whatever calculation it has. So you may call a function and then immediately after that call another function, and that's fine, right? We could put another function down here, and we'll call that one function B. It can work exactly the same. It's okay that you have more than one function workspace, and I'll color this one. Let's do this one green. And just like the other one, it's got its own input and its own output. This time, of course, if you've previously called a function, you could work on any of the values that were calculated by that previous function, depending on where they showed up. But the outputs would be different, right? In this case, the outputs would be whatever that function wants to output as. So I'm drawing the inputs there as blue because they're coming out of the base workspace, and the outputs as whatever color is the function workspace because that's where they're coming from. There's a careful nomenclature that we have to have here, which is you can call a function from another function. So what you can do is you can write a function, and from that function you can call another one. So we'll call this workspace or function C, and we'll make that one, what do I not have, yellow? Yeah, yellow. That's okay. You can do something like that. And here you're passing the data back and forth. Try and keep our colors matched as we go. This is okay to call one function from another one. What you should not do, although you are technically allowed to do, Matlab will allow it to do it, is you should never define a function inside of another function. So what I mean by that is function C that's sitting here should never be defined inside of function A, right? If this was a little tiny function, it should never be sitting inside of A like that, which you can do. It's called a nested function. Matlab will allow you to do that. I strongly discourage you from doing that because it messes with the scope of the variables. Scope is what we mean when we say some variables exist in some workspaces and not in others. The scope of the variables gets really confusing if you define it inside of another function. You can define them separately and then call one function from another. That's A-okay. In fact, the majority of the time that's what we do. But think really long and hard before you define a function inside of another function. It's usually not necessary, and it often will create more confusion than it's worth to do something like that. So this is sort of the general flow of information that we can expect. Remember, the only thing that's going through those arrows are values of data. It's never the variable itself that moves through those arrows. It's only the values that get passed back and forth, never the variable itself. And because of that, the nomenclature in there, or not really the nomenclature, understanding what variable is where and when can be a little bit confusing the first few times that you write functions. So let's look at the general syntax, and then we'll look at a few examples. So this is syntax for standalone and local functions, not for anonymous functions, which we'll get to a little bit later. Generally, when you want to write one of these, you'll say function. That's the keyword in Matlab, a reserved word. The output arguments come first, and they go in a square bracket. So you can say something like output 1, output 2, etc. You can have more if you want. It's okay, although there's guidance for that. Then you write whatever the function name is that you want. So for example, my function name. And then the inputs go in parentheses. So there might be input A, input B, input C. The code, of course, goes in after the function call, and then there's end. So it's not that much different from a script. The only difference between this and a script is you have the word function that goes up at the top, and you have to define the inputs and the outputs. There are some sort of caveats and guidelines. One thing is a requirement, and that's that the file name must match the function name. So here, if we were going to write my function name as an actual function, it would have to be saved as my function name.m. If you don't save it that way, Matlab won't know where to find it, and so it will probably give you an error when you go to call it. It won't be able to find it anyway. Generally speaking, you can have as many inputs and outputs as you want. But also think hard if that's more than 3 for either one of those. That's more just like guidance when you're writing a function. If you find yourself writing, 15 or 30 or however many inputs like that, you might be better off like passing them as a vector, or you might not actually want a function there. If you come across that in a homework, that's a red flag that you're probably doing something harder than the way that I intended it, and maybe stop by like office hours or something and ask me what I meant by something. It's fairly rare to need more than 3 inputs or 3 outputs for something. It doesn't mean it's wrong, it's just, it's kind of weird, right? It'd be like seeing a car with 7 wheels on it. Like, it's fine, it'll run down the road, but it's a little weird when you see it. But maybe there was a good reason for it. The inputs and outputs can be scalars, they can be vectors, they can be matrices, they can be arrays, or just generally any data type inside Matlab. So if you can create it as a variable, you can make it an input or an output. It doesn't have to be anything in particular. There should be only one function of a given name in your current path. The current path we haven't really had to worry about so far. The practical guidance for something like this is 1 per folder. The 1 name per folder is something that your operating system will enforce on you. You can't have the same file in the same place. It just won't let you have the same name on it. And so we'll just follow that general guidance. You can duplicate the file names in other folders, that's fine. But your current path will generally be your current path is usually your working directory, i.e. your current folder. There are ways to add more directories to your current path, but they're usually outside the scope of what you would need for like a homework problem or something like that. The names of inputs and outputs don't have to be the same as the variables you intend to pass to them. That's supposed to be an advantage. It's a good thing. It allows generalization. So for example, let's say you had a function like z is equal to my sum of x and y, and all z is the sum of x and y, as the name would imply. If you had that as your function, most likely you don't have to actually pass x and y to something like this, right? Instead of that, maybe you have something like in a script somewhere, you might define, width is 6 and I don't know, height is 8. And so you calculate, man, why would you ever want that? I don't know, let's call it width 1. I can't imagine a time where you would need to sum a width and a height, so I'm gonna rename them. Let's say you had 2 widths, right? And then you wanted to say total width is equal to my sum of width 1 and width 2. First of all, don't write a function to do that because you can just add the 2 together. But second of all, and more important to what we're trying to address here, is the values that I'm using as inputs and outputs to the mySum function are different from the variables that I've actually used inside of the function. That's generally supposed to be on purpose because the function is generalized, right? It's designed to just sum 2 things. It doesn't matter what those 2 things are. Those 2 things don't actually get passed to the function, it's just their values. So as long as width 1 corresponds to your x and width 2 corresponds to your y, it'll get applied correctly, right? It'll sum something up in the way that it should. And the last thing I'm going to do before we go on is just, it's important enough that I'm going to put it here again, even though I think I've already said it a few times. The variables in the base workspace aren't available in the function workspace, and vice versa. You only get the values, right? The variable itself doesn't go back and forth. Because they're not available, because they don't see each other, which the technical word for that is because those variables have different scope, you can use the same name twice. It can be a little bit confusing, especially when we get to local functions and they even show up in the same file. But you can use the same variable name twice, and they will have different interpretations, which is why I try to avoid using the same variable name. So let's say that we have that same mySum function up there. So the same mySum function, but we have a new script, right? We go into another script, and inside of that script, we say z is equal to 4, w is equal to 3, and therefore x is mySum of z and w. The weird part about this is z is defined in the script and passed to mySum as an input, even though z inside the function is used as an output. Right? That can look a little bit confusing because it's the same variable, but remember the variable itself is not being passed back and forth. It's only its value. So the way that this is interpreted is mySum is called and it takes the value of z, which is 4, and inside the function workspace assigns 4 to be x. And so now x is 4. Similarly, it reads the value of w, which is 3, and assigns that to y inside of this function space, calculates the result, assigns the result to z here, but now I've said actually call that x, which is really confusing, right? So it's another reason not to mix up your variable names. Try to create variable names that are distinct enough that you can tell the difference between a variable that's inside of my function and a variable that's used in my script. If you find yourself using the same one, it might be okay. There's probably nothing wrong with it, but it sure can be confusing when you then go to troubleshoot your function. Z is where we define the, there's a question on Canvas chat that Z is where we define the data of the output, define the type of the data. Yes, so the type of the data being output is defined inside of your function. It's usually defined implicitly. We don't have to declare that Z is going to be a double precision number. It's just whatever the sum is. On the right-hand side, that becomes Z. We also don't have to explicitly define or declare that Z now needs to be returned. The fact that we calculated Z and we said in the function declaration that Z is an output, that's enough for Matlab to know that it needs to return Z. We don't have to say something like return Z or output equals Z or something like that. Just calculating it is enough. So I'll give you a moment here to catch up, but also we're going to switch over to Matlab here in a minute. So if you don't have that up, you might want to pull that up. The midterm's out of 100. The base, the sort of core simulation is 65.
Gotcha.
Yeah.
Thank you.
If you look underneath that graphic that I have, on point number 5, there's an example of how you could calculate a theoretical score for a midterm. Yeah. I put those in there and I call them like optional or extra or something like that. Not in the sense that you don't lose any points for them, but because in the past I've had students respond fairly favorably to that, because what it means is if I present you with a problem and you have no idea how to do it, you don't have to bang your head against the wall for 2 hours trying to put something down on paper so that you don't feel so bad about it. If you don't submit anything for it, it's not like you somehow fail. I mean, you lose those points on that, but none of those draw from any of the other ones. So it's sort of my way of giving you permission to not stress out. If there's like one part of the exam you don't know how to do, it's okay, it's isolated, it's its own little thing. And as long as you know the points aren't there, you can skip it if you want to.
Okay, thank you.
Which actually you can do on any exam, right? Like anytime you've sat down on an exam, if you don't feel like answering a question, you don't have to answer the question. It's just there mostly for your mental health of not beating yourself up over not knowing how to do something. Yeah. Okay, so we're over in Matlab. We need to make a function. You make a function the same way that you make a script. There is the option over here under New. If you want to create a function, you can click Create New Function, and it will auto-populate a function. I usually find this more irritating than helpful, just because I have to delete the vast majority of everything on there, because it has nothing to do with whatever I'm trying to write. So you can get a template for a function where you can sort of recall all of the inputs and the outputs if you forget. I usually don't do that. If you create a new script the same way that we've been creating scripts before, this is also a function. All you have to do is type function at the beginning, and now you've got function instead of a script. So the function we're going to write is called myTrig, and it's going to take an amplitude, it's going to take a period, and a time as an input. We'll put end afterwards. I'm in the habit of indenting, although I don't think it's required. We'll calculate a frequency inside of here as 1 divided by period, and then we'll calculate y as the amplitude times the sine of the frequency times time. Right, just a basic sine wave plotter, right? But we've got some extra handles on there where we can adjust the amplitude and the period and that sort of stuff. So remember, one of the rules is that the function name has to be the same as the file name. So this myTrig on here, this file needs to be called mytrig.m. So when I go to save this, and I don't think that you can see this on Twitch, but when I go to save this, the pop-up window automatically populates the file name correctly. So generally, you just have to click save, and you should get that over in your current folder. The current folder is usually all you have to worry about in terms of a path to find your function. If your function's not in your current folder, most likely it won't be able to find it. You can tie yourself into knots creating multiple working paths or working directories. I tend to try to keep it as simple as possible, which is just put it in the folder that I'm currently working on. And if I need it somewhere else, I just copy paste it into that other place. So that's myTrig, and then we're going to write a script. I'm going to move myTrig over here to the right, just so that we don't forget about it. And then I'll create this script and just call it, I don't know, my script. And so now we'll practice a couple of different ways of using that function. So for example, we could calculate one value. We could define an amplitude as 3, a period as 2, and a time as 2. By the way, these values are entirely arbitrary. If you make a mistake and have 20 instead of 2, it's okay. We're just practicing inputs and outputs here. And then we'll create the result as myTrig of A, P, and T, which when you're entering that, if you've saved your function somewhere, Matlab should auto-populate this sort of little help pop-up that came up here to remind you what the inputs ought to be. And I think you can actually see that on Twitch right now. Notice that amplitude we're using as A, period is P, and time is lowercase t. That's what I said earlier that's what I meant earlier when I said the variables don't have to have the same names. It's okay that in the script we're calling amplitude A, and over in the function we're actually calling it the word amplitude. The value of A will become the value of amplitude inside of the function workspace, and we'll see that here in a minute. That'll be enough for now. We'll come back to a plot in a moment. When I run this script, over in my workspace over here, you can see that sure enough, I've got the 4 variables that I defined in the script, but I have none of the variables that were in my trig function, right? The variable amplitude, period, and time, and particularly frequency, do not show up in the base workspace because they don't exist in the base workspace. We passed some stuff over to myTrig, it calculated some stuff and passed a result back, and that result became the word result. It became the variable result. So we never have access to any of the variables inside of the function in the base workspace. Oh, okay. I saw a hand. It's one of those trends you get into where you see somebody's hand going up, so you stop. There are a few ways to see how that happens. There's actually two ways to do it, to look at the different workspaces. They both have to do with the debugger, and it's just different ways of enabling the debugger. The way that I use most often, and the way that I think is easiest for me, is you can put a breakpoint inside the function. So I clicked on the 2 over here inside of the function, and now if we run the script, the debugger will pause inside of my trig, and now we can actually see the workspace over here, right? If you look next to the word workspace, it says -my_trig. This is about the only way that you can see the function workspace. You can do stuff like print values and stuff, but I don't know, it's a little bit annoying to print a bunch of, to not only add all of the code, but then look through all of the output in order to see them. But you could do something like that with an fprintf or a display function. But now we can see that those variables really do exist, the amplitude, the period, and the time. And now if we step through this function, if we click step, it'll calculate the frequency. Right? So everything in there behaves the same as it did before. It's just a different set of variables because we're in a different workspace. We're now in the function workspace. And then we can click step if we want and continue on out, and it will eventually step out of the function and switch back now to the workspace being my script. And then I'm just going to hit stop since we don't need to do it. So that's one way to look at the workspace inside of a function. The other is, it's called step in, which is still in the debugger. If you put a breakpoint in the script instead of the function, let's say you put it right before the function is supposed to be called and you hit run, you'll pause right before you get to my trig, and up here we used to hit continue or we used to hit step, right, if you just want to go along with the next line in the code. Right next to this is the step in button. That will take you inside the function. So that will hop over here to the right, and now you can see once again the workspace has changed. It's just a different way of getting into the function. Whichever one is more convenient for you, you're welcome to do. Bless you. You can get weird results too. So here I'm going to click step in. You should be able to actually step into the built-in functions like sign. That one might be too low level to actually get into. Yeah, it actually skipped over sign. But a lot of its built-in functions, you can step into those as well, and sometimes that gets confusing because the guts of their functions are pretty strange when you start looking at them. So those are two different ways that you can see what the function workspace looks like. It is visible. It's just a little harder to see because if you don't have the breakpoint editor or the debugger enabled, it just skips right over the function, right? It evaluates so fast that you never see inside its workspace. In addition to calculating one value, you can pass indexed values as inputs or outputs. So for example, let's say we wanted the amplitude to be 1.5, the period to be 0.5, and now you wanted t to be a vector, right? 0 and 2 times from 0 up to 2 pi. You could pre-allocate something to hold that result and then iterate through each element of your t and store the result using my trig and the amplitude, the period, and t of I. So this gets back to the idea of you're not passing the variable itself, right? You're just passing a particular value. Which value? Well, each time the loop goes around, I will change a little bit as it's an indexing variable. It'll index into t and read that the value at that particular point and pass that over to my trig. My trig's gears will run, and then it'll spit out a value and assign the result to the ith location of z, which in this case is z of I, wherever that needs to be. Also notice, again, we changed the wording here, or the variable names. I do that on purpose just so that you don't think there's a particular style you have to do. There's usually a logical relationship, right? I called it amplitude over here, so I called it A here and AMP over here. There's some relationship to them that I know of in my mind, but Matlab doesn't care. You know, you could call this unicorns if you wanted to. It's fine. It doesn't matter. And then let's say we plot this one as t and z, and I'll plot it as a red line and say, hold on. And then the last one before I turn you loose on an example of your own. You can pass vectors if, and I'll put it as IFF, which means if and only if, the function is vectorized. When a function is vectorized, it's sort of one of those, what are they called, tautological definitions. It's very, very nearly that. Vectorized just means it can handle vector inputs and outputs. Vectorized. So that, of course, begs the question, is my trig function vectorized? It is, because we used the element-wise operators here. Right? When I divided 1 by the period, I used the element-wise division, which is something I had mentioned earlier you should get in the habit of doing. This is one of the reasons why that's convenient, is because oftentimes if you just use the element-wise operations and you're just doing, you know, the 4 basic math operations, addition, multiplication, division, and subtraction, you can usually automatically vectorize your function just by using those element-wise operations. So here, our function happens to be vectorized, but that's not always guaranteed, right? It depends on how you've written your function as to whether or not it can handle vectorized inputs. So for this one, we'll say something like amplitude's 1.4, period is 0.6. We'll do another time spacing. We'll say linspace is 0 to 2 pi. But now I'll assign the result to wave, and we'll calculate all of it all at once. So we'll say my trig of amplitude, period, and time. So this is a vectorized call. Vectorized in the sense only meaning I can pass a vector to it, and I'll get the correct value coming out the other side, which is another vector. So vectorized isn't a formal term inside of Matlab, like you can't run a test and find out if it's vectorized. It's just, did you write the function to be vectorized? And we can plot that one on top. We'll put that one as blue, just so that we can see the difference between the two. The plot on there is just to verify that it did in fact work and it generated a bunch of data. So if I run those, I'll get a plot and it'll look like that. So the plot has nothing to do with the actual function. It's just a way of verifying, yep, we sure did get a vector of stuff out. I'll just pause here for a second for anybody to catch up, or if you got any questions or anything like that. So for the last about 10 minutes of class or so, I'm going to outline a script and then ask you to write the function that I'm describing in the script. So I'm going to create a new script over here. We're going to do another random walk. So it'll start out similar in the sense that we'll have 1,000 steps, and we'll need some x's and y's. So we'll pre-allocate these to be the right size, just like we did for our random walk last time, right? So it's 1,000 zeros, and they're going to be column vectors. So they'll have 1,000 rows in one column. But then we're going to do the entire stepping procedure in one function. So we'll say for I is equal to 2 to the number of steps, or n step, I guess, in this case. What you're going to have to write is this function. So the desired behavior of this function is to calculate the new value of x and the new value of y based off its old value of x and the old value of y. So this will look like x of I and y of I, and it's going to be equal to take step. So that's your function name. You're going to have to call it take step. And the only inputs to this are the previous value of x, so that at I minus 1, and the previous value of y, in other words, that of y minus 1. So what you need to do is write the take step function, and it will calculate basically what we saw before, which is x new is equal to x old plus dx, and y new is equal to y old plus dy. But that's the most that I'm going to tell you, and you're going to have to use the structure of what I've got here to decide which of those are the inputs, which of those are the outputs, and then you'll also, inside that function, have to generate dx and dy. And that's the random number between 1 and 4 that we did on our random walks, and then it picks a dx and a dy as it goes through. So I'm going to leave this up here. I'll come back in probably about the last 2 minutes and outline a couple of the features of take step. But otherwise, I'm going to shut up and leave the remaining majority of the class for you to try to write that take step function. Also, if you're on Twitch, remember I'm over on Canvas chat, so if you have any questions, you can throw them over there, and I can pull them up there. All right, in the last minute or so, this is the most that I'm going to show, at least on stream. So if you want to work on the answers separately, you're more than welcome to. When I do post this video, the completed function will be included with the video, but it'll give you a little pause before you can go see the answers. But the most that I'll do to get you pointed in the right direction is the syntax for the function definition should look something like this. Maybe you don't need to call them x new and y new, but whatever you choose to call them, they need to come in the pattern of x and then y because of the way that I've defined them over here. I've asked for them to come out as x and y, so in my function definition, they also need to come out as x and y. You could flip them around and have them come out as y and then x, as long as you make sure that both of those are consistent, right? As long as they are both that same pattern. And similarly, the take step input, the old x and the old y, those have to come in the pattern of x followed by y, because that's how I wrote them over here. Typically, when you're writing your own functions, you make that definition the other way around, right? You write the function first and then pass the input arguments in the same way. This, because it's an in-class sort of challenge assignment, I flipped them the other way to see if you knew which one was which. So that's as far as I'm going to go on stream. I will stick around over in Canvas chat if you have any other questions. And like I said, the completed function will be uploaded with this video, but I'm not actually going to display the rest of the answer here. I'll let you work on the rest of that coding. Otherwise, I will see you either Friday in class or tomorrow, Thursday, in our lab hours, whichever one I see you in next. Have a good one, and we will see you then. Bye all.